And the reason it bothered Einstein and others is it would appear that something is instantaneously changing. And it's not just your knowledge of the system that's instantaneously changing. It would seem that the system itself is instantly configuring itself when you make some measurement. So you might say, well, this is nonsense. There must be something else. And it turns out that as far as we can tell, and a Nobel Prize was awarded for some of this research a few years ago. Then no, there's nothing hidden there. This is the way that the system is. But you think about that system of 2 qubits. Right? Think about it. So you've got these two things which can be up or down. There are 4 possible combinations of that system. You can have up, down, up, or down, down. 4 for the 2 qubit system. For a 3 qubit system, you think about it, ups and downs, you'll find out there are 8 possible combinations, and all mixtures of them. For 4 qubits, then it's 2 to the power 4. There's 16 possible combinations. We're talking about building quantum computers now in which we have 100, 200, 300 qubits, all in principle entangled together. The number of possible descriptions of that system, then, you have numbers that describe it. If there are 100, it's 2 to the power 100 different configurations, and any mixture of those things that are states of the system. So pretty soon, 2 to the power 100 for 100 qubits. What's the number of atoms in the universe? If you had 2 to the 500, you'd far exceed 500 qubits. The number of numbers you need to describe that system exceeds the number of atoms in the observable universe. But it's a thing that we can build. We can build just about. We're not far off being able to conceive, at least, of a network of 500 qubits. They're physical things. They're kind of like that big, some of them, right? So you have 500 of them in this room. So the power that's hidden in the description of a system like that is immense. And the thing that a quantum computer does is it uses that power, some of that vast computational or configurational power of the thing. It's very, very difficult to do. And we've not been able to do it particularly well at the moment. You'll read many papers online where obviously companies like Google, Microsoft, IBM are investing a lot of money in these devices because potentially they can carry out computations that no conceivable classical computer could make within the lifetime of the universe.